Hello, this is Fraser's problem set number 2 for kinematics. A train is traveling at 61 meters per second when an engineer sees a stopped train in the track ahead. So the engineer's in the first train. He immediately hits the brake and starts slowing the train down at a rate of 2.2 meters per second squared. The engineer in the stopped train sees the speeding train approaching and at the same moment begins accelerating away from it at a rate of 1.2 meters per second squared. It is close, but the closest the two trains get to each other is 12 meters. How far apart were the two trains when the engineers first saw each other? So when time equals 0. This is a pretty tough question if you don't understand, if you can't visualize what's happening. But by beginning, I'll just set up my given and required. I will have two trains. I will call train A as A train that's traveling 60 meters per second. Then train B as the one that stopped accelerating at a slower rate. So my V1 is 61.2 meters per second. V2, I actually don't care. Acceleration equals 2.2 meters per second squared, but this one's backwards. I'll erase my vector sign in a sec when I state my positive direction, delta TA. Well, time is always the same, so I don't have to do any subscript for that. Delta dA, this is an important thing. Then my forward direction, all right, forward equals positive. Therefore, backwards is negative 2.2 meters per second squared. Train B, V1 equals 0. V2, don't care. Acceleration, maybe I'll call it acceleration B equals 1.2 meters per second positive because it's going forward. Delta t I have already. I'm just going to write it again, same variable, and another delta t, but this one b. Now, I'm going to establish another variable over here called delta d0, meaning delta d when time equals 0. It's what we're trying to find, okay? We're also trying to find this along with t. So now I'll help you a bit by giving you some visual on how this problem should be solved. This represents distance. I have this train over here, this train over here. That's train A, train B, forward, backwards. Now, the distance between here, that's delta D0. It's the distance I'm trying to find. I'll denote t equals 0 over here. When you have the same set of points over here, but A goes over here right now, and B goes a little interval over here, that's when, let's say, delta t equals 1. It's not actually in proportion, but bear with me. Your distance between the two is going to be here. That's delta d1. What is delta d1 equal to? It equals to delta d0, but it's missing this distance. I'll call it delta dA, and it's gained this distance called delta dB. What I mean, it's actually just delta d0, the original distance, displacement, minus whatever you have here, delta dA, plus what you gained, delta dB. Now you can try to solve this by finding all the other ones, but that is my little visualization for you over there. I'll minimize it somewhere, and I'll keep this one here, somewhere here. Now let's go to analysis. I'll put this equation as my first statement because that's where we all come from. then I can define each of them. Maybe delta D is, yeah, just delta D is fine. That is going to be a function. Now delta D equals v1t plus 1/2 at squared. Forget about a delta. I'm not trying to do proper form. Well, I am, but anyways. So in that case, I'm trying to go for a first. What is my initial velocity? It's 61.2 t minus, because it's negative acceleration. What is my a? 2.2 meters per second squared over 2 t squared. Now, I'm going to keep it like this because I'll pick a different color like I always used. That's equation 1. Now, just to save time, I'm just going to paste this again over here. This time it's delta dB because I have a 0 initial velocity, like 0. Then I can just do 1.2 meters per second squared over 2. That's my a over 2, t squared. You know 0 is not going to do anything, so that's that. That's my equation 2. Oh, one more thing I forgot to mention in the given and required. Uh, delta D min, the minimum distance they reach is 12 meters. Let's just make sure it's distance so I don't have to add a vector symbol. Fraser's actually picky about this shit. The closest, I don't think it matters. It's just delta D with no vector symbol. Anyways, okay. Then we can sub this in. Sub in 1, 2. Now delta D will equal delta Z 0 minus bracket of 61.2 t minus 1.1 t squared, simplifying that a bit, plus 0.6 t squared. My delta D equals this 1.2 t, but this time it's gonna plus. You have two negatives here, so they plus. I'm just gonna do everything in one step. That is 1.7 t squared. Now we sub in another value. Sub delta D equals 12, which is the minimum distance, and I'll explain why I do that. But before that, write everything down. I'm rearranging this a little, so I'll tell you why. As you can see here, that's t squared. It's a parabola. It's quadratic, and the leading coefficient is positive. So you will have something that has a minimum, and that minimum, I can tell you, the height will equal 12, and this is it's a time graph, displacement time graph, and we're trying to find the t. When we find the t, we can find this point. In other words, we're trying to find what the constant coefficient is. So that's that. Now, as you can guess, this is going to get really freaking tedious because what I'm about to do is going to just traumatize you. It's called completing the square. So I'll leave 12 over there. First, I'll factor 1.7 now. It's going to be t squared. Let me do the math. 61.2, 1.7. Ooh, I will minus 36t plus delta d there. That will equal to 1.7. I won't bore you. It's just this squared. Then I try to take out what do I take out? 1.7 multiplied by, what was the number I was looking for? 18 squared plus delta d0. Now, I'm going to tell you, I don't really care what this number is. I just know the vertex is at t equals 18. I will just say, since t distance equals min when t equals 18 sec, therefore you can write an equation that substitutes stuff in, equals 12 equals 1.7. It's basically this equation again, 1.7 18 squared minus 61.2 18 plus delta d 0. Now, do the math again. I'm just gonna take a look at my cheat sheet. I will somehow get delta d0 equals 12 plus 550.8. Delta d0 would be 562.8 meters. There you go, that's your answer. Let's put a statement down. How far apart were they? As the two trains were 500, how many sig figs? 2? Uh-oh. 60 meters apart initially.